Universal ballasts are designed to operate within a wide voltage range, for example, 120, 240, and 280 volts. However, they have an optimal performance range within that spectrum. Typically, these ballasts perform best when the voltage is closest to the nominal voltage, such as 220 or 230 volts for a 240 volt nominal circuit. A voltage drop of 20 volts on a 240 volt circuit is significant and reduces the available voltage to 220 volts. This voltage drop can push the ballast outside of its optimal operating range, potentially affecting its performance and how long it lasts. The length of the circuit, 600 feet, contributes to the voltage drop because longer circuits have higher resistance, which further increases the voltage drop. There are several consequences of using a universal ballast with a 20-volt voltage drop. Firstly, reduced lamp output may occur because the lower voltage may not provide sufficient energy to the fluorescent lamps, resulting in reduced light output. Secondly, increased ballast heating can occur, as operating the ballast outside of its optimal voltage range can increase its temperature, potentially shortening its lifespan. Thirdly, in extreme cases, the ballast may fail prematurely due to the increased stress caused by the low voltage. To ensure optimal performance and longevity of the fluorescent fittings, it is strongly recommended to use the appropriate ballast with a circuit voltage of 240 volts. If the voltage drop is an issue, consider upgrading the wiring to a larger wire size to reduce the resistance and maintain the required voltage. The National Electrical Code, or NEC, provides guidelines for voltage drop in branch circuits. While it doesn't mandate a specific voltage drop limit, it recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders plus branch circuits. This recommendation is aimed at ensuring efficient operation of electrical equipment and minimizing energy loss. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times length times current times resistance per unit length divided by 1000. Where voltage drop is the voltage drop in volts, length is the one-way length of the circuit in feet, current is the current in amps flowing through the circuit, and resistance per unit length is the resistance of the conductor in ohms per 1000 feet. The resistance per unit length can be found in NEC Chapter 9, Table 8 for different wire sizes and materials. Several factors contribute to voltage drop in electrical circuits. These include the length of the circuit. Longer circuits have higher resistance and therefore greater voltage drop. The wire size also matters. Smaller wire sizes have higher resistance, leading to increased voltage drop. The current flowing through the circuit directly affects the voltage drop. Higher current results in greater voltage drop. The type of conductor material, such as copper or aluminum, also plays a role. Copper has lower resistance than aluminum, so it experiences less voltage drop for the same wire size and current. The power factor of the load also contributes to voltage drop, especially in alternating current circuits. Loads with a lower power factor draw more current, increasing voltage drop. To mitigate voltage drop, you can take several steps. Firstly, increase the wire size. Using a larger wire size reduces the resistance of the circuit, thereby decreasing the voltage drop. Secondly, shorten the circuit length. Reducing the length of the circuit decreases the overall resistance, which lowers the voltage drop. Thirdly, reduce the current. Lowering the current draw of the circuit reduces the voltage drop. This can be achieved by using more energy-efficient loads or by distributing the load across multiple circuits. Fourthly, use copper conductors. Copper has lower resistance than aluminum, so using copper conductors can help reduce voltage drop. Fifthly, improve the power factor. Improving the power factor of the load reduces the current draw, which in turn decreases the voltage drop. This can be achieved by using power factor correction capacitors. Finally, consider using a higher voltage. Increasing the voltage level of the circuit reduces the current required to deliver the same amount of power, which lowers the voltage drop. When selecting a ballast for fluorescent lighting, it is important to consider several factors to ensure optimal performance and longevity. These include the input voltage, which must match the supply voltage available in the building. Common voltages are 120, 208, 240, 277, and 480 volts. The lamp type is also important. The ballast must be compatible with the type of fluorescent lamp being used, such as Tate or T5 lamps. The number of lamps refers to the number of lamps that the ballast can operate. Ballasts are available in single lamp, two lamp, and multi-lamp configurations. The ballast factor is the ratio of the light output of the lamps when operated by the ballast compared to the light output when operated by a reference ballast. A higher ballast factor results in brighter light output but may also reduce lamp life. The starting method can be either instant start, rapid start, or programmed start. Each method has its own advantages and disadvantages in terms of energy efficiency, lamp life, and cost. The energy efficiency of the ballast is an important consideration for reducing energy consumption and operating costs. Look for ballasts that are labeled as energy efficient or have a high energy efficiency rating. The total harmonic distortion, or THD, is a measure of the distortion of the current waveform caused by the ballast. Lower THD values are desirable as they indicate less interference with other electrical equipment. The ballast case temperature is the maximum temperature that the ballast case is allowed to reach during operation. Exceeding this temperature can shorten the life of the ballast. The ballast lifespan refers to the expected operating life of the ballast, typically measured in years. Choose a ballast with a long lifespan to reduce replacement costs. Ballast warranty provides protection against defects in materials and workmanship. Look for ballasts with a long warranty period for added peace of mind. When troubleshooting voltage drop issues in electrical circuits, there are several steps you can take to identify and resolve the problem. Firstly, measure the voltage at the source and at the load. Use a voltmeter to measure the voltage at the power source and at the load end of the circuit. A significant difference in voltage indicates a voltage drop problem. Secondly, check the wire size and length. Verify that the wire size is adequate for the circuit length and the current being carried. Use the NEC tables to determine the appropriate wire size for the application. Thirdly, inspect connections. Check all connections in the circuit, including those at the source, load, and any intermediate points. Loose or corroded connections can cause increased resistance and voltage drop. Fourthly, measure the current. Use an ammeter to measure the current flowing through the circuit. Excessive current can indicate an overload or a short circuit, both of which can contribute to voltage drop. Fifthly, calculate the voltage drop. Use the voltage drop formula to calculate the expected voltage drop based on the wire size, length, and current. Compare the calculated voltage drop to the measured voltage drop to identify any discrepancies. Sixthly, check for overloaded circuits. Make sure that the circuit is not overloaded with too many loads. Overloading a circuit can cause excessive current draw and voltage drop. Seventhly, test the power factor. Use a power factor meter to measure the power factor of the load. A low power factor can contribute to voltage drop, especially in AC circuits. Eighthly, use a thermal imager. Use a thermal imager to scan the circuit for hot spots. Hot spots can indicate loose connections or overloaded conductors, both of which can cause voltage drop. Ninthly, consult with a qualified electrician. If you are unable to identify and resolve the voltage drop problem, consult with a qualified electrician for assistance. An electrician can perform a more thorough inspection of the circuit and recommend appropriate solutions. Universal ballasts can be used in various voltage applications but are most effective when the input voltage is close to the rated voltage. Operating a ballast outside of its rated voltage can lead to reduced performance and longevity. When dealing with circuits that have voltage drops, it is best to correct the source of the voltage drop before implementing a ballast.